Hello and welcome to Data Analysis with Python 0 to Pandas. This is a live online course being offered by Jovian.ml. My name is Akash and I am the CEO of Jovian.ml and I'm also your instructor for this course. And Jovian.ml is a sharing and collaboration platform for data science. We have been sharing all the course materials with you via Jovian, and you have been submitting the assignments and sharing what you have been doing with us via Jovian as well. A quick overview of the course. This is a coding first introduction to data analysis using Python, and we have video lectures every week with live coding on cloud-based Jupyter notebooks, and we have assignments where you can practice these concepts and you can do a project to earn a certificate completely free of cost. So today the lecture notebook that we will use is called Matplotlib and Seaborn tutorial. So let me open up the notebook. And if you have any questions during the lecture, you can ask them on the discussion forum that is linked here. Now on the notebook page, you will be able to see a run button. So I will be running the notebook right now, and you can run this after the lecture, so that you do not have to face a delay when thousands of us run at the same time. But we click run and then we click run on Binder. And while this gets started, this might take a minute or two to get started. In the meantime, if you have any questions during the lecture, you can ask them on the discussion forum. So this is lecture 5, data visualization. This is the discussion forum. And you can just click the reply button, the big blue button on the bottom, and ask a question. And click reply. And if you see a question that you like, just click the like button. All right. So coming back, we've clicked the run button and selected run on Binder, and that has brought us to this page. So now we have a Jupyter notebook running in front of us. So let me just open up the notebook here, and I'm going to click kernel, restart and clear output. So that is going to clear all the outputs, and we can just see the code cells and execute them for ourselves. I'm also going to toggle the header and the toolbar, but you need not hide it because the toolbar has many interesting and useful operations that you might need. So today's topic is data visualization using Matplotlib and Seaborn, and we've been building towards this slowly. So we've talked about the basics of Python. We've learned numerical computing with NumPy, analyzing tabular data with pandas, and now we're looking at data visualization. And you can run this code. We are currently running it on Binder, but you can also run this code on your computer. So the instructions for running it on your computer are given here. Okay, so let's get into it. Now, data visualization is the graphic representation of data. So what it involves is producing images that communicate relationships between the represented data to viewers. So the idea here is that a lot of the data that we deal with is in the form of numbers. It's in the form of tables or data frames or CSV files, and it's not really easy to look at a lot of numbers at once and understand something. But if you take the same numbers and then represent them using some kind of a picture or what is called a graph or a chart, then that leads to a better understanding of what the data represents and what the relationships between the different data points are. And in this lecture, what we are going to look at is some popular data visualization techniques, and we'll understand how to implement them using Python libraries, Matplotlib and Seaborn. So to begin with, let's import the libraries. So we'll import matplotlib.pyplot. That is the module that is used for doing most of the basic plotting. So we'll import matplotlib.pyplot with an alias of PLT, because that is the most common alias that is used in the data science domain. And then there is also a Seaborn library, which provides a Seaborn module, which we'll import as SNS. And this library is built on top of Matplotlib, and it provides many convenient methods that help you avoid writing a lot of code in basic Matplotlib. Okay. And apart from these two import statements, we also have this magic command matplotlib inline. What this does is this informs Jupyter that you want your graphs to show up as outputs below the cells where you've plotted them and not as pop-ups. So without this line, sometimes you may see that your graphs show up as pop-ups. Okay. So that's the setup. Now we've imported matplotlib.pyplot as PLT and Seaborn as SNS. And to get started, we will study one of the simplest types of charts or graph data visualization techniques, and that is called line charts. And a line chart simply displays some information especially a sequence of numbers as a series of data points or markers, and these data points are connected by straight lines. So let's see what that means. So here we have some data. Here we have a Python list called yield apples, and it contains 6 numbers. What this represents, it's an imaginary data set, but it could be a real one as well. So what this represents is the annual yield of apples in tons per hectare over 6 years in an imaginary country called Kanto. So there's a country Kanto where they grow apples, and we've simply measured the annual yield of apples in tons per hectare over the past 6 years. Okay. So ultimately those measurements turn out to be numbers like this. So now we have the yield of apples, and by looking at this, we might wonder what the trend is looking like. So we have a certain idea by looking at this that it seems like the yield is growing over time, but it's not very clear how fast or slow the growth is and whether this growth is likely to sustain. So immediately the simplest thing that we can do is we can plot it on a two-dimensional XY axis coordinate plane, and we can plot these points on the coordinate plane. So the simplest way to do that is to use a line chart, which you can plot using plt.plot. So we say plt.plot and give it a sequence of numbers, and that sequence of numbers now gets plotted. So you can see that this was the number at the 0th index, 0.895. This was the number at the first index, 0.910, and 0.920, and so on. So already we can see that it looks like the yield of apples is growing with time, but it appears that the growth is slowing down. So it seems likely that over time this will flatten out around 0.95 unless we make some technological improvements or there is a significant change in climate or things like that. So that is the power of visualization. Just a simple graph. This is already giving you a lot of information. Now, one thing you may have noticed here is when we call plt.plot with yield apples, it draws the graph here, but it also gives an output. So this output is basically the result of the plot function. So the plot function returns whatever was called. And in this case, it returns a matplotlib.lines.lines2d object. And we may not want to always look at this in the output because we are mainly concerned with the graph. So one thing that you can do is you can include a semicolon after your code. So if we call plt.plot with the semicolon, you can see here that now we do not have that output, the line 2D output. We simply see the graph being plotted. And in general, while using matplotlib, you might want to just include a semicolon with the last statement so that you do not see an unintended output. Okay. So now we have a line plot and it's already telling us a lot, but let us enhance this plot step by step to make it more informative and beautiful. Okay. So the first thing that we are going to do is we are going to customize the x-axis of the plot. Now you may have noticed that here we know what the values or the yields of apples are, and this is plotted along the y-axis, but we do not know which years this data is for. And without that, this plot is not very informative. So the first thing that we can do is we can change the x-axis to show the actual years. So here now we have two sequences. We have years, which is 2010 to 2015, and then we have the yield of apples. And now we are passing to the plt.plot years. So this will form the labels on the x-axis, the ticks on the x-axis, and then the yield of apples. These will form the points on the y-axis. So in a sense, we are actually giving it now a list of points. So for 2010 on the x-axis, we want to point to 0.895. For 2011, we want to show 0.91 and so on. So we plot it now. And now you can see that you have the years 2010, 11, 12, 13 and 14 and the corresponding values. So that's great, but it would be nice as if we share this chart with someone, it would be nice to include information about what these axes represent. And these are called labels for the axes. So we can add labels for the axes to show what each axis represents using the plt.x label and plt.y label functions. And now one interesting thing to note here is that we've already called plt.plot, and any other plt functions that we call within the same Jupyter Notebook cell are going to get applied to the same plot. All right. So we can actually write these in any order, and all of these will get applied to the same plot that comes out as the output of this cell. So we call plt.plot, and that plots the two lines. And then we say plt.x label and set that to year. And then we say plt.y label and set that to yield in tons per hectare. and that gives us this result. So we have the year here, and then we have the yield in tons per hectare. So now this plot is starting to get a little better. Now what would be interesting is that, okay, we can see that the yield for apples is growing, but we may want to know if this is happening for other crops as well, or is it just that the whole agriculture sector is growing, so this does not really say a lot about apples in particular. All right, and so what we might do is we might want to plot multiple lines within the same graph, and to do that is really easy. So all you need to do is invoke the plt.plot function multiple times with different data within the same cell. So here let us construct some more synthetic data. So here we have data from 2000 to 2011, because in a range the last value does not get included. So we have 2000 to 2011. So there are 12 years, and then we have the data for apples and the data for oranges for 12 years. Now already you can see here there are about 25 numbers you are looking at here, and it's very hard for you to make an inference even if you spend a few minutes looking at all the numbers. And this is where a visualization is going to help. So now we're going to plot plt.plot years, and then plt.plot years with apples and years with oranges. So the x-axis remains the same. This is not necessary, but in this case we just want to keep the x-axis the same. And then we set an X label and the Y label, and then we plot it. So there you go. So now you can see that we have two lines for apples and oranges, and it seems like, since we already know that this was the graph for apples, it seems like the graph for oranges is going down. So based on this, you may form a hypothesis that it's probable that maybe the demand for oranges is falling or the demand for apples is growing. So maybe some of the land that was being used for apples is now being used to grow oranges or something like that. And once you have a hypothesis like that, then you can go back and investigate and find out if this is indeed the case. So this is great, but just by looking at this graph, it's not quite clear which line represents what. So we already knew this was apples, and that's how we could tell. But you can actually include what is called a legend. So you can simply say plt.legend, and into the legend you can give a list of labels for each of the lines. So the labels will get applied to each line, and then you have the title. This title is applied to the entire chart as a whole. So now you see here, you can see a title, crop yields in Canto at the top of the chart, and then you have the apples and oranges, and then you have the yield in tons per hectare and the year. Now, as we add more lines, sometimes it can get difficult to understand where the points exactly are. So for instance, if we want to know the data for 2005, we have to estimate it a little bit. So we can tell that 2005 is around here, and so the value is probably this one, and that is about 0.908 or something like that. It's not very clear sometimes, especially in a graph like this, which seems to be growing linearly, where the points exactly lie. And this is where you can actually add markers to the points. So to show markers for the data points, we can simply use the marker argument of plt.plot. And matplotlib supports many different kinds of markers like circles, cross, square, diamonds, and so on. And you can actually see a full list of markers here. So if you visit this page, you just search for matplotlib markers. You can see what the value that you need to provide to the marker argument and the symbol it displays on the screen. Okay. So let's try out a couple of examples. Now we are going to plot the yield of apples, and we are going to use a circular marker for it. So apart from the line, there will be a circular marker, and then for the yield of oranges, we are going to use an X marker or a cross marker. So let's run this. So you can see now you have circular markers here, and then you have cross markers here, and they're also represented in the legend. So this is a little better, but you might want to style these lines and markers. Suppose you want to use these in a presentation, then you might want to include some of your brand colors and backgrounds and things like that. So to do this styling, to style the lines and the markers, plt.plot, the plot function, supports many arguments for styling them. So you can use this color or C argument to set the color of the line. And once again, there are many inbuilt colors that are supported within matplotlib. So here you can just search for list of colors in matplotlib. And you can see here that there are a lot of colors already supported. And if you want to use a color other than this, then you can use the RGB hex code of that specific color to set a custom color as well. So you can set the color and you can set the line style. So you can have a solid line or you can have a dashed line. Maybe you have one primary metric that you want to show using a solid line and the rest you want to make them dashed. You can do that. And then you can set the width of the line. In each line's width can be set separately. You can set the size of the markers and you can modify some colors of the markers as well, like the edge color, which is the outline of the marker, the edge width, the width of the outline, and the face color, which is the color of the filling in the marker if it has a filling. And you can also change the opacity of that specific line plus markers. So check out the documentation of plt.plot to learn more about what you can do. And here we've just included a few examples. So for apples, we are going to use a square marker and the color is going to be blue, and it is going to be a solid line with a width of 2 and the marker size of 8, and then the marker edge and the marker color is going to be different as well. And then for oranges, we are going to use the red color and we are going to use a dashed line. So we use 2 hyphens to indicate a dashed line, and then the line width and the marker size, etc. will also be different. And we are also setting an opacity of 50%. So for the oranges. So once we run this, now we see that now we have the crop yields in Canto, but now you can see that the lines are a little bit wider and the lines have bigger markers, and then the orange one is a little less opaque. It has a opacity of 50%, whereas the blue line, which is apples, is solid. So this is how you can modify the lines and the markers. Now there's one shorthand here, because often the most common thing that you want to do is to specify the type of line, the type of marker, and the color of the two things. So there is a FMT argument that you can pass into plt.plot, and that can specify the line style. So the way you specify it, you specify the marker first, then you specify the line style, and then you specify the color, all within a single string. So for example, here what we're doing is we're saying ears, apples, and then FMT is the third argument that goes into plt.plot. So you do not need to call it as a named argument. So you can just pass in the third argument. So here we are saying that it will have a square marker, it will have a solid line, and it will have a blue color. Whereas oranges, we are saying that they will have a dashed line and it will have a circular marker and it will have a red color. So you can use this shorthand from time to time when you are quickly drawing some graphs, just to differentiate between different lines. And once again, you can see that we've still copied over the X label, Y label, title, and legend. What you can do is you can take all of this. If you have plots that you want to draw in a certain way, you can take all of these and put them into a function, so that each time you pass in 2 lists of values, apples and oranges, all these styles are applied to them, right? So you can use all the nice things that Python offers, things like functions, modules, and so on, to organize your code and organize your graphs as well. Okay, now one exception here is that if in the format argument, if you do not specify a line type, so in this case we are plotting ears and oranges, and here instead of specifying a solid or a dashed line, we have skipped it entirely. So then the line will not be drawn and only markers will be drawn. So you can see here that you can just see the markers and not the lines. And this is a useful thing to have as well. Sometimes you might want to have a line for a particular set of data and you want to show points for another. So you can do that too. Okay. Now, if you want to change the size of the figure, sometimes the figure might be too small and you might want to increase the height of it, or you might want to increase the width of it. For that, you can use the plt.figure function to change its size. So you simply say plt.figure and then you set fig size, and then you give a tuple. So you can experiment with this, what the tuple does. So let me just try out 2, 2, and then you put in a sample value and see what 2, 2 gives you, and then use that to maybe make some changes. Let's try 8 and 4. So yeah, that way you can change the size and the aspect ratio of the image. Now already we are starting to draw pretty good line graphs, but one interesting thing that we can do just to make our charts a little more beautiful is to use the Seaborn library. So now we are going to use the Seaborn library for plotting, but one of its use cases is also to just improve improve the look and the feel of the graphs that we draw using Matplotlib without doing anything additional. All you need to do is import Seaborn. So we have imported Seaborn as SNS and then use the set style function. So the Seaborn contains a bunch of predefined styles within the library, and you can get the full list of predefined styles here at this link. So for instance, one of the predefined styles is white grid. So when we say sns.setStyle white grid, what happens is a certain set of styles get applied to all Matplotlib charts, and this includes some background, some font colors, some other configurations, and we'll see an example of that. And this gets applied globally. So now this style is going to be used for any plot that we make using Matplotlib or Seaborn. So now we do plt.plot, we plot apples and oranges in the exact same way that we did before, and we set the X label, Y label and legend. So we're not doing too much styling here. And you can see that you can already see there are some changes. So the font is slightly different, and there is now a grid. So the grid makes it slightly easier to see, okay, where the values lie. For instance, you can see that this point is 0.93 and then this is 0.94. So this point is probably around 0.934. You do not have to draw an imaginary line in your head from here to here. You can just follow the grid. So that's pretty useful. And one style I like, so this is the white grid style. One style I particularly like is the dark grid style. So you can just call sns.setStyle dark grid. And now we have the exact same code that we had in this cell that we're going to run, but it's going to have a slightly different style. So here now you see that now we have a graph where it has a background. So the part of the graph has a background, and then it has a grid as well. And then the colors are slightly different too. If you had used the default colors, then those would be slightly different too. You can see here that these colors are slightly nicer than the default colors that you will get with Matplotlib. So this is one of the benefits of using Seaborn, that it automatically makes your charts a little more beautiful. Now the next thing that, and here's one more example of that. So you can see that this we've only called setStyle once, and then every subsequent plot that we do will automatically have that style. Okay. But if you want to, you can also edit the default styles within Matplotlib directly. So Matplotlib has, so you can import Matplotlib, and then there is something called RC params inside Matplotlib. In fact, you can just check it out. Let's say we just print it out here, matplotlib.rc params. You can see a whole set of values here. You can see there are probably hundreds of values, and you can change the font size. You can change the font family, you can change the background colors, you can change the default, you can change the default ways, the default grid, whether you should show a grid or not, and a lot of other things like that. You can change the default marker style, you can change the default line style, and so on. And the way to do it is to simply set matplotlib.rc params. So here, for instance, I'm changing the font size, the default font size to 14, and I'm changing the default figure size to 9,5. So just making it slightly bigger, and then setting the figure.face color to, this is basically transparent. So here, let me just take this same graph. So you just keep this graph, this picture in mind, and let me just take the same graph and plot it here. And you can see now that this graph is bigger. So this is nicer when you want to present, or let's say do a video. So I'm doing a video with you, I can show you this, and it's a slightly bigger graph, easier to see. And sometimes you might want a small graph as well. Now, one quick note here is any graph, if you want to just download it, you can simply right click and click save image as in whatever browser that you're doing, that you're using, and you can just save the image to a file. With that, we complete our discussion of line charts, and let us just save and upload our notebook to our Jovian.ml account. So we just call pip install Jovian, and then we import the Jovian library, and then we commit, the notebook using jovian.commit. So you can change the project name here to whatever you like. And this will ask us for an API key, which we can get from our Jovian.ml account. So here I'm going to my account and clicking copy API key, and then I'm pasting the API key here. And what this does is this captures the entire notebook and puts it online for me to share and continue working on. So even if the binder instance shuts down now, we have the notebook on our profile, and you can see here that it contains the charts that we have drawn. And if we want to continue our work, we can simply click run and click run on binder once again to continue. So moving forward, next we are going to look at a scatter plot. So a line plot is primarily used to represent a bunch of values in a sequence, whereas a scatter plot is used to visualize the relationship between two variables as points on a two-dimensional grid. Okay, so what does that mean? A good way to look at it is by looking at an example. And for the example, we are going to use a data set that is already included within the Seaborn library, but you can also use any CSV file and import it using pandas. So here Seaborn contains a utility function called load dataset, and into load dataset we can give one of the predefined datasets that are included with Seaborn. So we have flower, and that returns a data frame in pandas. So this is our pandas data frame for flowers df, but you could just as easily have done pd.read CSV here and passed in a path to a CSV file, and that would have worked well too. So let's study this dataset. So it looks like this dataset contains 4 or 5 columns. So it contains, it is information about flowers. So these are some measurements made on a total of 150 flowers. So here we have 150 rows. So for 150 flowers in a garden, let's say, we've measured the sepal length, the sepal width. So sepal is a part of the flower, and then petal is another part of the flower. So then we've also measured the petal length and the petal width. And we've noted the species of the flower. So this is a typical data set that you might work with. All right. And this is you can learn more about it. Here's a link to the Wikipedia page. It is called the Iris flower dataset. And the first thing that I wonder here is, okay, it seems like there are a lot of values of sepal length, width, petal and width, but the species seem to be limited. So the first thing that we can check is what were the species here. So if we just check the flowersdf.species.unique, so it turns out that there are 3 species: Setosa, versicolor and virginica. Now let's try to visualize. You can see a lot of numbers here. So there's a sepal length and a sepal width. Now you might wonder, is there a relationship between the sepal width and the sepal length? Like when the length increases, does the width increase, or vice versa, right? Or is there an opposite relationship where if the length is low, then the width is high? Currently, by looking at just these numbers, it's hard to tell. You may have some idea that, okay, for 4.9 you have the width is 3.0, but for 5.1 the width is 3.5. So there seems to be an increase, but the relationship seems to be different here. Like the width is higher for flower 2, but the length is higher for flower 1, right? So it's not very easy to tell the relationship, and we can't even look at and grasp all the numbers at once. That's where we might to visualize the relationship, our first instinct might be to create a line chart using plt.plot. So we may call plt.plot, and remember that we need to pass in an x-axis, a bunch of values for the x-axis and a bunch of values for the y-axis, and then all those points will be plotted and connected with lines. So here we say flowers df.sepal length and flowers df.sepal width. So this is a series, or the column, this is a column from the data frame, which is a series object, a pandas series. And that is similar to a list in the sense that it can be iterated over. So matplotlib can automatically work with anything that looks like a list. So a numpy array will do, a pandas series will do, and so on. So we plot it, and that leads to this plot, right? So this plot is not very pretty or very useful, because, and why do we end up with a plot like this? Because there are 150 values, and all of those values are in this range of, like in a small range of 4.5 to 8, you have 150 values for the sepal length. And then similarly in the small range of 2 to 4.5, you have 150 values of sepal width. And there is no natural order to either of these values, right? These are all completely random measurements. Earlier what we had was we had ears. So we know that the ears would increase. So at least one of them was ordered, but here there's no order. So in cases like this, especially you might, first time you might try something, just start with a plot like this and see, and if you get a bad output like this, then maybe a line chart is not the best thing to draw here. And the next thing that you should try is to draw a scatter plot. Now let's see a scatter plot. It's going to be somewhat similar to this, but instead of the lines, you will just have points. So for scatter plot, we use the scatter plot function from Seaborn. Now Matplotlib also allows you to draw scatter plots, but it is a little bit limited in its power. So the scatter plot function in Seaborn is much nicer to use. So we just say sns.scatterplot, and then we say flowers df, so dot sepal length. So this is the x-axis, and flowers df dot sepal width. These are the points on the coordinates on the y-axis, the corresponding coordinates. All right, and then once we call it, this is what we get. So now all the 150 flowers, the points have been plotted. Like for instance, this represents a flower with the sepal width of length of 5.5 and a sepal width of something around 2.3. And you can see that the scatter plot has automatically picked up the names from the series and shown them here as axes, as labels for the axes. And this is one of the nice things with Seaborn. It saves you a few lines of code every time by automatically doing the right thing. But we were concerned about the relationship between length and width, but there doesn't seem to be a clear relationship here. In fact, like the points seem to be all over the place. But if you notice carefully, you will notice about 2 or 3 clusters. So you can see this one cluster of points here. These are all together, and then there are some outliers. And then you can see another cluster of points around here. These are all together, and then you can see another cluster of points here. So there seem to be 3 clusters of points, and you might have a hypothesis here. Okay, there are 3 species of flowers, and now we can see about 3 clusters of points. And it makes sense that across different species of flowers, we may not really see a relationship, but maybe if we just study a single species separately, maybe we might be able to find a relationship. All right. So this is where you can use the hue argument to scatter plot. So here now we are specifying flowers df.sepal length, sepal width, and then we are also specifying a hue. So what the hue says is that you pass it another column or another series which has the same length as these two. So for each flower we also know a species, and now for each distinct value of species, the corresponding points will get a different color. Okay, and then one other thing that we are doing is we are increasing the size of the points. So you can just make the size of the points larger, and you can try experimenting with a few values here. I tried it and I found 100 to be a good value. Okay, so now we have this graph. So now here we have the sepal length once again and the sepal width, but now the dots are slightly bigger because we have a bigger size, and they are of 3 different colors. So now we have Setosa, which is blue. So all the Setosa flowers are here, and as we had guessed, so they do form a cluster. And then versicolor are orange, and then virginica are green. And now you can also visually see there does seem to be a relationship here, that in Setosa flowers the sepal length tends to be a little bit low, whereas the sepal width tends to be high compared to other flowers. And there is a general relationship. Probably as the flower grows, both the sepal length and width grow proportionately. So there seems to be like a line that you can cut through. Obviously there are more factors involved, so this is not a perfect relationship, but you can see that there's some kind of a rough linear correlation. Then similarly you can observe a similar trend for versicolor, maybe not so much, but versicolor values are somewhere in between both the width and length. And then you have virginica. So virginica tends to have pretty long sepals, but the width seems to be pretty small. And virginica also seems to be more spread out, so it's not as concentrated or as close to a linear relationship as we have seen in the others. So then we might want to go back and learn more about virginica. Maybe there are multiple classes of virginica flowers, or maybe they behave differently for a certain region. So this can inspire research when you plot a graph in a fashion like this. Okay. And now we have a great plot, but it is missing a few things. One, it would be nicer to make this figure a little bit bigger, so we can do that. And the way to do that is because Seaborn builds on top of Matplotlib. So whenever you call an SNS.scatterplot or a function like that, along with it, you can also include some PLT functions on the same within the same cell. So you can say plt.figure, and that will apply to the same chart that is being drawn by scatterplot. And then you can say plt.title, and that will apply to the same chart as well. So in this way, you can mix and match things from matplotlib and Seaborn. And this interoperability is sometimes really useful. So now we have a title, and now you see that because we had a more wide graph, the legend was moved to this corner, and that allows us to see some points here. Then we have the sepal width and the sepal length as well. So this is how you modify a plot drawn using Seaborn. Now, one other thing I want to mention here is that Seaborn has a great inbuilt support for pandas data frames. So instead of passing each column as a series, you can also simply pass column names and then use the data argument to pass the data frame as the source for the data. So for instance, you can say here we have sns.scatterplot, and here we can say that we simply want to use the sepal length column as the X and the sepal width column as the Y, and the hue should be the species column, and then pass in a single argument called data, where we pass in a data frame. And then Seaborn will automatically pick these columns from the data frame for the respective axes. So you can see here we get back the same result. So that's it for scatter plots. Now, I hope you're getting a sense of when you might want to use a line plot and when you might want to use a scatter plot. And even if it's not very clear yet, the best thing to do is just to try it out. That's the best thing about Jupyter Notebooks and about Python, that you can just first draw scatter plot and then draw line plot and see if it looks good, if it serves your purpose. If not, draw scatter plot. Maybe that will help you. That will help you visualize the data better, and so on. The next plot that we're going to look at is called a histogram, and a histogram represents the distribution of data for a single column or for a single type of variable, essentially. So what do I mean by that? I think the best way to look at it once again is using an example. So once again, we load up the flowers data set, the flowers data frame, and let us just look at the sepal width this time. So let's not concern ourselves with other columns. So histograms are typically just the data for a specific column. Now you're looking at a bunch of values here, and it seems like there is so you might wonder, okay, what is the range of sepal width in terms of the smallest and the largest value? And one way to do that is just to do flowers df dot sepal, or you can just do flowers df dot describe. Remember the describe function on data frames. So if you call the describe function, then for each numeric column, it tells you a bunch of statistics. So if we look at sepal width, it seems like the minimum value is 2 and the maximum value is 4.4. So you already know a little bit. And then this mean is 3.0. So that means 3.0 is the average, and then there is standard deviation of 0.43. And okay, that's good that now we know more than we did earlier, but it is still not very clear where the values lie. If we had to count, okay, how many values lie between 2.5 to 3 and how many lie between 3 to 3.5, we might not, that way. And then if we were to plot that somehow, then it would be easier to visualize the relationship, visualize the distribution of the values along this range. And that is where the histogram comes into picture. That within the range of values that a variable takes, so sepal width in this data set takes the values from 2.0 to 4.4. So within the range of the values it takes, how are the measurements, how are the data points distributed? So let's just see it now, and then we'll talk a little more about it. So here we are saying plt.hist, H-I-S-T, for histogram, and we simply pass in the sepal width column to it. And we've also set a title, distribution of sepal width. Okay. So now we have this graph. So let's just spend a couple of minutes understanding what this graph represents. So here as we saw earlier, the range of values is from 2 to 4.4. Now this entire range of values taken by sepal width is split into 10 parts here automatically. So that's the default setting, and we can change that. So it is split into 10 intervals, and you can probably guess that this would be around 2 to 2.2, and this would be 2.2 to 2.4, and this would be 2.4 to 2.6, and so on. And then what we do is we look through the column, we look through this data of sepal width, and then we count how many values lie in this range. So in this case, about 5 values lie in the range of 2 to 2.2, and around 4 values. So we draw a bar which goes up to the height of 4. And then similarly, we count the number of measurements that lie within the range 2.2 to 2.4, and then we draw a bar which shows the number. So this number seems to be around 7, and so on. So now when you study this, it seems like somewhere around 3.0. So it seems like from 2.9 to 3.1, somewhere around that range, there are 36 measurements. So that is where a large number of measurements lie. And then it seems like there are more measurements on the larger side than on the smaller side. So from 3.2 to 3.3, let's say 3.4 or something like that, you have another 30 or so measurements. Okay. So already now we know how the values are distributed, the values of sepal width, the measurements, how they are distributed in the range that they take. Now these bin intervals are currently a little bit arbitrary. We may not want to check between 2 and 2.2. That's a little bit arbitrary. We may want to have a fixed number of bins, or we may want to decide what the intervals, the bins. So each of these intervals is called a bin. So interval is a mathematical term and bin is the statistical term used with histograms. They mean the same thing. What we can do is we can specify the number of bins. So if we, let's say instead of the 10 bins, we wanted to see just 5 bins. So here now we can split the entire range into just 5 bins. And now we can see that, okay, obviously now if the bins are larger, the interval is larger, then between 3 to 3.4, it seems like you have a total of close to 70 values. Or what we can also do is we can specify what should be the points at which bins should be created. And the way to do that is to give a list or an array as an input to the bins argument. So there's a bins argument. So here we are giving an input. Let's just see what this does. So we are to the bins argument, we are passing np.arange. So let's see what that does. So np.arange 2, 5 and 0.25. What this says is create an array that starts at 2, goes up to 5, not including 5. So goes up to 5 and it takes steps of 0.25. So we have 2, 2.25, 2.5, 2.75 and so on. Okay, so now we can take this array and we can give that as a list to bins, and then the matplotlib will automatically create an interval between each two consecutive numbers. So 2.5 to 2.25 to 2.5, 2.5 to 2.75, 2.75 to 3 and so on. So these are much nicer boundaries to have, I think, in this case compared to what we had earlier. So you can see now we are going between 2.0 to 4.5, and then we have these nice intervals that line up with our measurements. You can also have bins of unequal sizes if you want to. So here we have simply set the bin measurements to starting from 1 going up to 3. So that's a bin of length 2. And then starting from 3 going up to 4. So that's a bin of length 1, and then a bin of length half. So there you go. Now we have 3 unequal bins, and obviously when the bins are unequal, the data points that lie in each bin, the number of data points will change. But you can still see that even though the 3.3 to 4 bin is a little bit smaller, half the size of the first bin, it still has twice as many values. So this is how you can play around with histograms. Just change the number of bins and the size of each bin. But I hope you get the idea that the basic idea here is it tells you how a single variable like the sepal width, how its measurements are distributed along the full range of values that it takes. Okay. Now, similar to line charts, we can also draw multiple histograms on a single chart, and we can reduce the opacity of each histogram so that, because there are bars here and these are opaque bars, if one of the histograms is going to be drawn on top of the other, and typically this is the order in which they are listed. So the first one that you list is drawn at the bottom, then the second command that you include is drawn on top of it, and so on. So some of the bars of the first histogram may get hidden by the second, and to avoid that, what you can do is you can simply set a lower opacity for each of the histograms. So what we are doing now is we are taking the same flowers data frame, but this time we are going to filter out just a specific data frame for each species of the flower. So here we are saying flowers data frame where the species is equal to Setosa, and similarly we have versicolor, and similarly we have virginica. So you can check here that for Setosa DF, you only have setosa flowers, and you can verify the same for versicolor and virginica. So you have 50 flowers in each, and you can check that. Now let us plot setosa and versicolor using two different histograms. And once again, you can set the color using the C argument, but by default, if you simply plot two of them, Matplotlib will automatically cycle through different colors. So let's plot them, and we are plotting them with an alpha or an opacity of 0.4. It might be helpful to add a legend here as well, because we don't know which one is which here. So if I just do plt.legend, and here we can say setosa, that should be the first one drawn, and versicolor. All right, so here we go. So now we have setosa and we have versicolor. So setosa is blue. So it seems like the setosa flowers, the sepal width seems to be on the higher side, mostly higher than 3.0. Whereas for versicolor, the sepal widths tend to be on the lower side. So mostly between 2.2 to 3. And that's already a lot more information than we had earlier. So this is one way to show multiple histograms. But what we can also do is we can stack histograms on top of one another. So we can, rather than showing this on top of, rather than when I top, like above. So here actually it is, both are overlapping, but what we can do is we can put this bar above the previous bar. And the way to do that, it is actually a little bit easier, is into plt.hist, instead of passing a single set of values, you can pass multiple arrays. So we can pass the setosa df sepal widths, and we can pass the versicolor df sepal widths and the virginica sepal widths as a list. And then we simply specify the same set of bins that we want. And then we say that we want to stack them. So we set stacked equals true. And once we do that, you can see here that the bars get stacked, right? So there are these many. So for setosa, we can see that in the range of 3 to 3.25, there are these many setosa flowers and these many versicolor and these many virginica. Excuse me. And these many virginica flowers. And now this histogram obviously is a lot more informative than before. So you can see the overall trend, but you can also see the trend for each species of flower. So you can see that setosa lie in this range, and then virginica in this range, and versicolor in this range. So let us save and commit our work before continuing. Okay, so now we've looked at line charts, scatter plots, and histograms. The next type of chart that we're going to look at is called the bar chart. And a bar chart is conceptually very similar to a line chart in that they show a sequence of values, except that what we do is we use a bar for each value. We show a bar for each value rather than we're showing points connected by line. And let's just see that as an example. So let's maybe first draw a bar chart for this data. So here once again we have the data for apples and oranges, and then years. So first we might want to draw let's say plt plot, and we say years and apples. Oops. Yeah, so here we have a line chart showing the yield of apples. So that goes from around, it seems like it goes from in the range, it goes from around 0.35 to 0.9 and then goes up and down. Now a better way, now this is great to study the trend, line charts are great for that, but they're not very useful for comparing individual values, right? So you can tell probably that this value and this value is a little bit higher than this value, but it's not visually, it's not very obvious. And that is where when you want to compare data across multiple years, then it might be better to plot a bar chart. So we can just say plt.bar, and the only difference here is instead of there being points and these points being connected by lines, you have a bar for each year, and then the height of the bar goes up to the data points value, which is the yield of apples, right? So we just say plt.bar, and here we have the yield of this is the yield of oranges. So let me just plot oranges here. Yeah, so this is the yield of oranges, and you can see that the same thing is represented here now, and you can see that now it's not that easy. It's maybe not as easy as a line chart to visualize the relationship on how the trend looks, but it's definitely easier to compare across. So if you want to say between 2003 and 2005 or between 2004 and 2001, it's very easy to look through and identify. And one trick here is that you can actually draw bar charts and line charts together. So let's take this plt.plot, put it here. Let's also add a marker here. So let's make it a red line. Oh, sorry, let's make it a circular marker with a dashed line and a red color. And let's also take the bar chart here. And let's put the bar chart behind. So first we will plot the bar chart, then we will plot the lines, and let's set a title. Okay, so there you go. So now we have a graph which shows both the same data, yield of oranges, both as a bar chart and as a line chart. So now it's easier to study the trend, and now it's easy to compare multiple values as well. And you can choose based on what looks better for you for that particular data set. You can choose which one to use, or you can use both. And then like histograms, you can also stack bars on top of one another. So for instance, here we can plot the yield of apples, and then we are plotting the yield of oranges, but we do need to specify that the bottom, we need to use a bottom argument for the second bar. So here we are specifying that the bottom for oranges is apples. So this tells that the bars for oranges should be drawn at particular heights. So here you go. So now you can see the trend for apples. So you can see how the yield of apples changes. You can see how the yield of oranges changes. And then you can see how the overall yield, let's say this is the yield of fruits. So what is the overall yield of fruits? How is that changing over time? Okay. So that's the bar plot. And this was a convenient case because here we already had a single value for each item on the x-axis. So for each year we already had the average yield, but that may not always be the case. Sometimes we may want to show not a single metric, but we want to show an average of many columns on a bar chart. And let me show you what I mean by that. And for that, we are going to use another dataset that is included within Seaborn called the TIPS dataset. So this dataset contains some information about customers visiting a restaurant over a weekend. So from Thursday to Sunday, a bunch of customers visit a restaurant, and for each customer, we note down a bunch of information. So for each customer, the information that has been noted down is the total bill, the tip given by the customer on the bill, the sex of the customer, and whether the customer was a smoker, and what time or what day it was. So whether it was Thursday, Friday, Saturday or Sunday, what time of the day it was, whether it was lunch or dinner, and what was the size of the party. So how many people were there in that group along with the customer in total. Okay, so this is the TIPS data frame. And you can see here that one of the questions that you might want to ask is, what does the average bill look like on a particular, or on every weekday or on every day? So how does the average bills between Thursday, Friday, Saturday and Sunday compare? And to do that, you might have to do like a group by operation. So actually let's try to do that maybe. So let's say we have tips df, and you might do group by. Yeah, so you might do group by, and on group by you may group by day, and then from that group by you may select simply the total bill, and from that you might then do mean. So now you have, this is the average total bill for on the days of Thursday, Friday, Saturday and Sunday. Okay, and then you can draw bar plot here. So you can just say plt.bar, and here you can just pass in tips df dot, let's just call this bill average df. So now we want to provide an x-axis and a y-axis. Now unfortunately in the bill average df, the day has become the index, so there's no longer a day column. But what we can do is we can simply use the index column. The index column is called day, and then we can pass in the bill average df dot total bill. Okay, and now we have the total bill, average total bill compared across Thursday, Friday, Saturday and Sunday. But we had to go through 2 steps here. We had to first do this group by operation, and then we got the average, and then we plotted it. But since this is such a common thing to want to know, that you may want to see that for, let's say, for days, but then you may want to see how does the average bill compare across men and women, how does the average bill compare across different let's say smokers and non-smokers and so on. And that will involve all of these calculations. And that is where we can use the Seaborn library, which provides helper functions so that we don't have to do this calculation. So instead of doing that entire calculation yourself, what you can say is you can call SNS, so seaborn.barplot, and the bar plot is the plot for drawing bar charts in Seaborn. And you can specify, so here we have specified the data as the tips df data frame, and here we have now specified the day as the x-axis. So we now say that we want to group on the day and we want to average the total bill, right? So on the x-axis we have the day, and on the y-axis we have the total bill, and Seaborn will automatically calculate the average and now plot a graph. So now you can see Thursday, Friday, Saturday, Sunday. We see a very similar graph, similar to what we saw here, but this is done automatically for us. And another thing this includes here is this line. So this line tells you that what was the variation in the values. So I think it's called confidence interval, if I'm not wrong. Basically what it tells you is that 50% of the values lie in this range from here to here. So you can see that there's a lot more variation on Friday in the bill, even though the bill is lower compared to Thursday. On the other hand, on Sunday, the bill seems to be the highest and there seems to be a much lower variation. And then Seaborn has also automatically added these labels here: Thursday, Friday, Saturday, Sunday, the day, and the total bill. So in a lot of cases, I find myself using sns.barplot rather than doing plt.bar, especially when there is some average to be computed. Okay. One thing that we can also do is, just like a scatter plot, we can specify a hue argument, and that can be a third argument. So let's specify hue as sex. So we know that here in this data set we have male and female. So let's specify hue argument apart from the day and total bill. And now you can see that for each day you have 2 bars. So you have 1 bar for male and 1 bar for female. So it seems like on average you can see that the bill for the female is lower than the bill for the male. And there also seems to be, if you look at Friday, there also seems to be more variation in the bill from males rather than the bills from females. And then you can look closer into the data set. Maybe you can go and investigate and figure out why this is the case. Why is the total bill lower for females? Is it, and similarly, you can specify, you can just say filter on smokers. Let's see if the average bill for smokers is lower or higher. Yeah. So if a person is a smoker, it seems like on average their bill is higher, but then there seems to be a lot of variation. So I'm not sure if we can make that assessment, if we can make that inference very confidently, but that seems to be true on average, except again on Friday seems to be an exception, right? So the correlation between total bill and smoker is not as high as the correlation between total bill and or the average total bill and sex. Now one thing that you can also do is you can make the bars horizontal simply by switching the axes. So you can go from day total bill to total bill day, and that will switch the axes and draw the bars horizontally. And sometimes these are slightly nicer to look at, and it's really up to you, and like on a case by case basis you decide what looks better for your use case and do that. A good point where you might want to make it, you might want to make these horizontal bars is if, let's say you had a lot of values here, right? So if you had a lot of values here on the x-axis, you may instead want to make them, let's say the x-axis was countries and not days of the week. So then you would need to show 200 countries, and that's very difficult to show. So rather what you might want to do then is use a horizontal plot. So you can show a list of 200 countries here, and then the y-axis could represent, let's say, something like population. All right. So that's it about bar plots. And once again, let's save and commit our work before continuing. And the next kind of chart, so we are only looking at a few common charts here, the ones that are used most frequently. And in fact, if I have to tell you from my experience, around half of the plots that I tend to end up drawing turn out to be line plots, sometimes bar plots, and then those where the line plots do not make sense tend to be scatter plots. And histograms are useful when you are visualizing a specific variable, just a distribution of values. So histograms are pretty useful as well. And then there is this last one called heat map, which you will use from time to time. Not very often, but this is also one of the most common plots. So to understand what a heat map is, It's used to visualize a two-dimensional data like a matrix or a table using colors. Now that's probably not telling you a lot, but the best way to understand it is to look at an example. So what we are going to look at is we're going to use a data set called flights. Once again, this is included within Seaborn. So we say sns.load dataset flights. So here what we have is we have data for years, for a bunch of years. So starting from 1949 to 1960, and then for each month, starting from January to December for each year, we have the total count of passengers in thousands. So these are the count of passengers who visited a certain airport. So this is the footfall at the airport. Okay, and we don't know, I can't recall which airport this is, but let's assume it's an airport. So in January 1949, 112,000 passengers visited the airport. In February of 1949, 118 passengers visited the airport, 18,000 passengers, and so on. We have this data for 1949 to 1960. Now what we may want to know is, what does the trend look like? What does the trend of passengers coming to this airport look like? Is it increasing or is it decreasing? And we could do a line plot. So we could simply do plt.plot. So this we have, let's call this df. Let's simply do df.passengers. And it seems like there's an increasing trend, but you can see that things go up and down. And a nicer way to visualize this, in my opinion, would be to use a heat map. And for using a heat map, we could, first of all, we have to represent this data as a matrix. So here what we're going to do is we're going to use the pivot argument. We're going to use the pivot function on pivot method of a data frame. And we're saying that we want to pivot on month and year. And what that does is that creates, that sort of puts this data frame into more of like a matrix kind of a format. So now instead of the rows, instead of the columns being year, month and passengers, the months become the rows. So for each month we have one row, January, February, March, and all the way up to December. And for each year we have a column. So here we have 1949, 50, 51, all the way up to 1960. So there's still a pandas data frame, still the same data represented in a different way. And then the element at a particular, the value at a particular position. So let's say 51 February, this is the number of passengers in thousands, of course, that was there in the original data frame. Okay. And you can look up the documentation of pivot to learn more. But now we have this matrix of values, all of which is representing a count of passengers across. So one axis is the months and one axis is the years. Okay. And looking at this matrix of values, it's not easy to tell what the trend looks like. It seems like the values increase over the years, and it seems like the values increase up all the way up to June, July, and then decrease. But it's still not very obvious. And this is where we can use a heat map. So all we need to do is first get the data into this format, right? And you've seen how to do that. You can using the pivot method, or sometimes you can simply use a NumPy two-dimensional array with all of these values. And then we pass in this into sns.heatmap. So once again, this is a Seaborn, something that Seaborn gives you. And we're also setting a title here. So once we create a heat map, we get this nice visualization. So this is a visual representation of the same information. So instead of the numbers, now we see colors. And then you can see that the darker the color represents a lower number. So you can see this legend here on the side, the strip. It tells you that the darkest color, black, is closer to, let's say, 100 passengers, whereas the lightest color, which is close to a very pale color, that is about 600,000 passengers in thousands. And then now you can see the trend a little bit better. So it seems like over the years we go from dark to bright. So that means over the years the traffic seems to increase. And then within a year we go from dark to bright and back to dark. So that's the same trend that you can see everywhere. So it seems like once again that the traffic increases up to June, July, and then decreases once again. Okay. And this heat map is pretty useful here to visualize this relationship in a single glance. Then once again, what we can also do is we can change we can also show the values here apart from the colors. So we simply set a0 equal to true. So just use the argument a0 equal to true, and that will also show the numbers. And then we have the C map. So here it uses this color map of going from very dark to very bright. I actually would prefer the opposite here. I would want a lighter color to show a smaller number of passengers, and a darker color to show a higher number of passengers. So you can search for color maps in Matplotlib, and there are a lot of pre-included inbuilt color maps. I'm going to use a color map called blues. So that's going to be slightly different from what you saw before. And this is what that looks like. So now we are showing the number of passengers, the actual value, and we are showing a background color behind it, and the background color goes from very light, showing a small number of passengers, to very dark, showing a high number of passengers. So here now you can see that once again the same trend, that the number of passengers increases over the years, and the highest footfall seems to be around July. Okay, so that's the heat map, and the main reason you may not draw a lot of heat maps yourself, but you may come across a lot of heat maps as you're looking at tutorials or notebooks drawn by other people, and then over time you'll start to see when they make sense, and then you can start including them in your own visualizations. So next up, we've looked at 5 types of graphs, and that's pretty much it in terms of the types of plots that we are looking at. But Matplotlib can also be used to display images. So to display an image, let's first download an image from the internet. So this is the image. You can follow this link to see where what it looks like. And we are using the URL retrieve function from the urllib.request module for this. Okay, let's just try that again. Yeah, so the image is now downloaded. Now before the image can be displayed, it has to be read into memory. And to do this, we use the Python imaging library, or the PIL module. And from the PIL module, we import the image class. And then to the image class, there is a method called open. So this creates an image. So this is an image, and then you can check the type of this. So this has a type of pil.jpg image plugin.jpg image file. So image.open automatically converts this into a certain class within a certain object of a certain class within the PIL library. But internally, PIL is simply using a NumPy array, a 3-dimensional NumPy, to represent this image. And we will look at that array. But first, let us display the image. So to display the image, we can use plt.imshow. So we just say plt.imshow, and then we put in the image, the PIL image object. And this is what the image looks like. So it seems like the image itself is the image of a graph. It is actually a meme about a bar plot, where one of the bar plots has a very high variance. The confidence interval is very large. And so the other bar plot says, sorry, we just can't trust you. And that's the image. And it seems like this image is displayed, but along with this image, an axis is also displayed. Now you see this is drawn by Matplotlib. So you see it seems like it goes from about 0 to 480. And again 0 to 600 and something. So this image is of height 640, and this image is of width 640, and it is of height around 480. And you might know that images are represented using pixels. So each point, so when we say 480 is the height, so there's a pixel or a point. There are 480 points vertically, and then there are 640 points horizontally. So in some sense, it is a matrix of points, right? So it is a matrix of points with 480 rows and 640 columns. Now what does each point contain? So each point is actually a point on the screen, which is called an RGB pixel, or a red, green, blue pixel. So how images are displayed on the screen is that you have a red pixel which shines with a certain intensity, and then you have a blue pixel which shines with a certain intensity, and then you have a green pixel which shines with a certain intensity, and all of them together form one pixel of a color image. And as we vary the intensities of the red, green, and blue lights, that leads to all the different colors that we see on our screens, millions of colors. So that's what an image is. And if you want to see the internal representation of an image, so you can simply do np.array and pass in the image object, and that will create an image array. And then you can check the shape of the image array. So as you might expect, the image array has 481 rows and then 640 columns. So that means there are 481 cross 640 pixels points on the image, and then each point is again has 3 values. So these 3 values are the color intensities of red, green and blue, and typically these values go from 0 to 255. So we're getting a little bit into like how images are represented and so on. It's a little bit outside the scope of this tutorial, but let's look at it anyway. So you can see here that there's a 3D array, and then each pixel is represented using 3 values R, G and B. And then these values can go from 0, which means that the red light is completely turned off, to 255, which means that the red light is completely turned to a full value of like bright red, and then similarly green and blue. Okay. So that's a little bit about images, but the key idea here is that you can actually display images using plt.imshow. And now if we do want to just see the image and not see the axis and the grid lines, so then we can simply turn off the grid. So we say plt.grid false, and then we turn off the axis, and then we say plt.axis off. So this is a little bit odd, where for grid you say false and for axis you say off. But you know, these are just same things that you can look up. You can always just search online how to disable the grid in Matplotlib. So by grid, these lines, these white lines that seem to be cutting the image, and then the axis, by axis, these x-axis and y-axis, which has a bunch of values here. And we also can set a title for this plot. So here once again we have the actual image now. So it seems like the image had a border internally, that's why you see a border, and we have a title for it, and then you can look at the image. Okay. Now we can, since I mentioned that this image is a NumPy array, we can actually also display just a part of the image. So all we need to do is we need to select which columns and which rows we want to show. Let's say we simply want to show this portion, right? And if I go back to this image where we had all the axes, so if we just want to show this portion, then I might start from picking from the 120th row to, let's say, the 320th row, and I might pick somewhere from the 100th row to the 100th column to the 300th column. So that might give me just this section. So that's what we do here. We say img array, and here we say 125 to 325 and 105 to 305. So we've picked certain rows and certain columns. And now when we pass that into plt.imshow, it will only display that particular section of the image, right? So you can see here now it only displays this particular section from a certain set of columns and a certain set of rows. So that's how you effectively, what this means is we have zoomed into the image. So that's it about images in Matplotlib. Then we have plotting multiple charts in a grid, because we've seen different types of charts. We've seen how to plot images, but there are certain cases where you might want to show certain charts side by side, certain different charts, right? Not just, let's say, 2 lines within the same plot, but you may want to show a line plot and a scatter plot and an image side by side. And this is possible. This is actually really easy to do in Matplotlib. So let's look at it. So the way we do it is to first call plt.subplots, and then in plt.subplots we pass in the number of rows that we want to see and then the number of columns. You can see here we get back some 1 2 3 4 5 6 plots. There are 2 rows and 3 columns, and then you can change this and see how that varies. So now here we have 3 and 3. So that's a good starting point. Now the next thing that you might want to do is, because you can see that these values are overlapping a little bit, so you can actually specify spacing between these. So you can just say plt.tight_layout, and then in this tight layout you can specify a pad argument. So I'm just going to set pad equals 2. So now that is going to give some space. So now you have space between each of these graphs. So it's starting to look a little bit better. And now we need to start filling these graphs. So to start filling these, we need to use the result of plt.subplots. So plt.subplots returns 2 results. So it returns a figure, so something called a fig, and then it returns axes, and we'll see what each of these mean. But yeah, let's just get the return values out, and let's just look at what the axes contain. So the axis, it turns out, is a NumPy array, and this NumPy array just contains some what is called an axis subplot object. So each of these is an object. So if we check axis.shape, it has the same shape that we had set. It has the same shape that we had set for within plt.subplot. So 2 rows and 3 columns. So if we just check axis 0, 0, so that seems to be an axis.subplot function, right? Axis.subplot object. Now this subplot object is something that you can use for drawing plots. So just as we do plt.plot, we can do axis, we can pick a particular subplot axis like that object, and then we can say plot, right? So axis 0.plot, and then here, let's say we want to plot a line chart. So let's say we want to plot the yield of oranges. So we say ears, oranges, and once again, we want to make this a circular markers and have a dashed line and make it red. So we can do that. And now you can see that we've plotted oranges inside this small subplot. Let's go one step further. We can once again take this axis 0, 0 and let us set a title for it. So let's set the title yield of oranges. Let's also plot apples maybe. So for apples, we are going to use a square, and then we are going to use a blue color and solid line, and let's set a legend. So you can do all of that just within that specific plot. So we can set legend, and the legend is apples and oranges, or yeah, let's move apples up. So apples and oranges. So we use it exactly like plt.plot, but there are a few differences. And to understand these differences, you can refer to the documentation. I'll provide a link below. So to set the title, you need to actually call set_title. And then if you want to set labels, so let's say we want to set X label and Y label. So in PLT, we were doing .x label, but here you need to do set_x label. And this is just it's just a specific thing, an implementation detail within matplotlib, which unfortunately we have to deal with. So you just say set_x label. So X label is the year, and then similarly we set the Y label, and the Y label is the yield in tons per hectare. Okay, so that's it. Now within that particular axis, we have drawn a pretty complicated chart here. You can see here. Okay, maybe I don't want a legend. Maybe the legend is too much in a small graph like this. So yeah, let me just hide that. You can see now, you can see this is crop yields. So now if this is getting a little bit too cramped, you can increase the size of the figure. So you can specify a fig size, and let me set the fig size to 12,9, and let's see if that makes it better. Okay, so now the figure is a little bit better. So now we have crop yields. Maybe we can even add back the legend. Alright, so there we have it. Now we have the crop yields for apples and oranges in yields tons per hectare, and then we have the year here, and then we have a title for the graph. So that we've done for the first one, and similarly we can do it for the next one as well. So now we pick axis 0, 0. We pick axis 0, 1. So that would be this one. Now here, let's do a scatter plot. But to do a scatter plot, we need to use sns.scatterplot, right? So we say sns.scatter plot, and here maybe we want to visualize, let's say flowersdf.sepal length and flowersdf.sepal width. So let's just take that and put in sepal width, and then we want to give it a hue. So we set the hue to flowersdf.species. Okay, and then we want to set the size to 100, the size of the dots, and we want to give it a title. So we want to give this a title of sepal length versus width, let's say. Now one issue here is that we've not passed in the we've not specified which axis the scatter plot should be drawn on, and that's where Seaborn provides an AX argument, and to this AX argument you can specify axis 0, 1, and here this one should also be 0, 1. Okay, so we've now specified the axis. So for when you're using matplotlib, you can directly call functions on the axis, but when you want to use Seaborn, you simply pass in the axis into the Seaborn scatter plot or whatever function you're using. Okay, so let's run that too. Oops, it seems Okay, so we need to set dot set title. All right, so this is where I get confused sometimes, but we need to call set title for the axes. Okay, so now you see here, now we have the sepal length versus width. Species are Sentosa, versicolor and virginica, and these are the plots. And similarly, you just extend this forward. So here once again, we are creating a plt.subplots. We have used a figure size of 16,8, and then we are plotting, here we are plotting a line graph. Then here we're plotting a scatter plot. So these two we just did ourselves. Then we can also similarly here, now we are plotting a histogram. So in the third position, we are plotting a histogram. So for histogram, we directly use dot hist on the axis 0, 2. Then we are plotting a bar plot. So here is a bar plot from the restaurant bills dataset. Then here we are plotting a heat map. So on like axis 1, 1, and then we are passing the same heat map. We're passing the axis into the sns.heatmap function. And finally, we are plotting an image. And for that particular axis, we are hiding the grid, and we are hiding all the axis, like the x-axis and y-axis. And then finally, we are calling plt.tight layout to give some space between these. So once we do that, once we use subplots, and then in each subplot we draw something, here we end up with a single image. So you can see this, if I drag this around, this is a single image. In this single image, we have 6 plots, and in this 6 plots, we have all the different kinds of graphs that we've drawn. So let's do a quick review as well. So first we looked at a line graph. We saw how to use the plt.plot function to draw a line graph. And then we saw that you can include, you can add a x-axis by including a bunch of values for the x-axis and a bunch of values for the y-axis. Then you can also add labels for the x and y axis using plt.xlabel and ylabel. You can also add a title to the chart using plt.title. And then you can add markers. You can add a legend, and then you can modify the style of the markers and the lines using various arguments to plt.plot. So all those also apply to the axis.plot function. Then we looked at the scatter plot. So we learned that a scatter plot is used to visualize the relationship between two variables, especially when there are a lot of values within a small range. So here we compared sepal length, and we just plotted the values, and we did not see too much of a relationship, but then we introduced a color or a hue to decide the color of the dots. And that turned out to give us more information, that now we could see that each species has a sort of an independent relationship. So that was a scatter plot. Then, and we also saw that a scatter plot or so scatter plot was created using sns.scatterplot, so the Seaborn function, and any Seaborn function has great support for pandas data frames. So instead of passing full lists of values, you can simply pass in column names, and then you can pass in the data frame using the data argument. Then we looked at the histogram is used to visualize the distribution of values of a single variable. So for instance, sepal width, we saw how the values of sepal width, how they are distributed in the range of 2 to 4.4. It seems like a large number of sepal width values lie in the range of 3 to 3.25, about 50 values to be exact. And then there are a smaller number of values in each range. So that gives you like a probability distribution. And we saw that we can stack histograms for multiple species. So we did a filtering, we created a list of values for each species, and then we used different colors to plot them so that we can see the overall relationship as well as the relationship for individual species of flowers. So that was the histogram. Then we looked at a bar plot. So our bar plot, in this case, we used the restaurant bills dataset, and the bar plot was used to represent the average bill on a weekday, the average total bill on each weekday, and to be able to compare them side by side. So for instance, we could see that the bills on Sunday were the highest and the bills on Thursday were the lowest. Then we also introduced a hue, so either a sex or a smoker or things like that, which would then show two plots side by side for each value on the x-axis, right? So that we could compare male and female as well. So that was the bar plot using sns.barplot. For histogram, we had used plt.hist. Then we looked at heat maps. So we looked at heat maps to visualize flight traffic into a particular airport over time. So from 1949 to 1960. And then we saw how the footfall increased over the years, but within a year, the footfall increased up to July, and then it tended to decrease, right? And a heat map was a good way to visualize that in a compact fashion. And finally, we also looked at how to display images. So we first load up an image using using pil.image.open, and then we can display it using plt.imshow. We also learned that images are actually in Python are represented using NumPy arrays with a certain number of rows, columns, and pixel values. So there are 3D arrays, and you can actually select a specific slice of the image and just display a small part of the image. So that's what we looked at as well. Now this is just a small selection of what's possible, and there is a lot more that you can do. So what I would recommend is, I have pointed to a few resources here. So I've pointed to a data visualization cheat sheet. So let's go through these one by one. So I pointed to a data visualization cheat sheet, which takes everything that you've learned here and then a few more plots and gives it to you in a very simple format that you can use as a place to copy paste from. Because with data visualization, what I often struggle with is that I know what I want, but it's very hard to figure out what the right syntax should be. So here we have included some examples for line plots, scatter plots, frequency distributions, heat maps. There's something called a contour plot, something called a box plot, which we've not covered, and a bar chart. So you can see simple examples, 1 line, 2 line examples, and you can simply copy over this code whenever you are, and use this as a reference whenever you are working on a visualization project. Similarly, we've pointed to a gallery of Seaborn plots and Matplotlib plots. So you can see what's possible with Seaborn and Matplotlib. So there are a whole different variety of plots that you can draw, and you can combine different kinds of plots in very interesting ways to create some really good visualizations. And the good thing is that these only take a few lines of code, especially with Seaborn. So for instance, if we open up this, so here you can see that this is just a few lines of code, less than 20 lines of code, and you get this beautiful visualization. And all of these Seaborn contains example datasets, so you can just try it out using these example datasets. So do try it out. If you just do it once, you're going to get a good idea, a good handle over Seaborn. Then similarly, we have this gallery for Matplotlib. Now, since Seaborn builds on top of Matplotlib, about that. So for Matplotlib, you will have to write a little more code, but Matplotlib is equally powerful ultimately, and it gives you a lot more control over your plots. So you can open up any of these examples and see. And then we've also pointed you to a documentation and a tutorial for Matplotlib. So here's a great tutorial that goes into a lot more depth. So it may take a few hours to work through, may take a couple of days, but you can work through this great tutorial that goes a lot deeper into Matplotlib. And this is by the same person from whom we borrowed the 100 NumPy exercises. So if you like this tutorial, just definitely give them a star. So with that, we complete our discussion of data visualization. I guess one of the questions that commonly gets asked is, should I use Matplotlib or Seaborn? And do I even need to use Matplotlib? What does Seaborn not contain? Well, so I tend to use Matplotlib especially for line plots and for simple histograms, because it's so easy to use. You just call plt.plot, and also for displaying images. So you just call plt.plot and put in some data, and then you can progressively enhance it. So whenever there's a simple plot to be drawn, just use Matplotlib. But whenever you're doing something a little more complex, like you want to have a scatter plot across 2 dimensions, and then you want to use a color as a 3rd dimension, and you can also use a 4th dimension to decide the size of the dots. So that's something that we did not look at, but that's possible too. So Seaborn is when you want to do more with your graphs, and that's when you would use Seaborn. So I would use Matplotlib for more simpler stuff like lines and histograms, and Seaborn for the rest. Now, in terms of how to choose the right plot, a good rule of thumb is to just try out a line plot, and in a lot of cases it can give you a good enough result. But then once you want to go beyond, then you start looking through this list. Okay, a scatter plot makes sense here. Will it be interesting to use a heat map here? And a lot of these things just come from experimentation. Now take the same data and try to draw different kinds of plots with it, and see which plot gives you the most information and presents the information visually in the best fashion. All right. And as you experiment with it, you will start to cultivate an intuition for which plot to use where. Now, one last thing we should do is to just commit our notebook from time to time. Remember that we're using Binder, which is a temporary online service, so it can get shut down if you leave the computer idle for some time. So whenever you're working on Binder, just do commit from time to time. Okay. So with that, we complete our discussion of data visualization. So let us open up the course project. This is one of the most interesting parts of this course. So the objective of the course project is to apply all the skills and techniques that you have learned during the course onto a real world data set. And the thing about the course project is, well, to get it accepted, there is a certain evaluation criteria that you have to complete, and we'll talk about that. But then it's really open-ended in the sense that you can do as much with it as you want. You can end up drawing dozens of different types of graphs and answer many different questions. You can combine data from many sources. So use this to really practice all the skills that you've learned. Don't take it as something that you just have to submit. Take it as something that you will showcase on your portfolio. And we'll tell you a lot about that as well, that how you can showcase this on your portfolio later on your LinkedIn profile or elsewhere. So let's open up the starter notebook. The starter notebook contains all the information, all the guidelines for the course project. So the first cell of the starter notebook contains guidelines, and then there is a template that you can use, but you do not have to use this template. You can start from scratch too. The way to start from scratch is to go on your Jovian.ml profile and then click new notebook and select blank notebook, and that will create a blank notebook that you can start working with. But in this case, I'm going to use this starter template, and then I'm going to click run on Binder. So let's just give that a minute to load. And coming back here, if you have questions about the course project, once again, there is a discussion going on. So you can ask questions on the discussion thread, and all the instructions are given here too, the same guidelines that are there in the starter notebook. So you can refer to them here too. Let's give this one more try. Okay, so while the Jupyter notebook starts up, let's start going through the guidelines. So as I mentioned, that this is the starter notebook, and you will pick a real world data set of your choice, and then you will apply all the concepts that you've learned in this course to perform exploratory data analysis. Okay, and this seems to have opened up. So let me just open up the Jupyter notebook here. Alright, so the first thing, the step one, is to select a real world data set. So you can find and download an interesting real world data set, and we have pointed to a lot of interesting data sets in the recommended dataset section. So you can just scroll down below and you will find recommended data sets, and we'll spend a little bit of time there too. And the criteria is that this data set should contain tabular data, which is rows and columns, and preferably in a CSV, JSON or Excel formats, or other formats that can be read using pandas, because we have used pandas primarily for this course, and if you're unable to read the data using pandas, you will not be able to analyze it. If it is not in a compatible format, then you may have to write some code to convert it to the desired format. So remember, we also had a discussion about reading and writing to files. So you may have to read it using pure Python and then write it back into a CSV or a JSON format, which can be read using pandas. Okay, I would suggest that if you're not too comfortable with Python yet, don't do that. Just pick a dataset that is already in the CSV format and just run with it. But if you are feeling comfortable, if you really like a particular dataset, it's not in a CSV format, then you can just convert it into CSV as well. Then the dataset should contain at least 3 columns and at least 150 rows of data. Now this is important because so that there should be enough in the project. If it is just 1 column of data and 100 rows of data, then you're not going to have enough to showcase when you present this project, let's say while you're applying for an internship or a job. So just pick a data set that is large enough. Now when I say at least, this is just a lower bound. You can pick data sets with tens of thousands of rows of data. Probably bigger than that will slow you down. So restrict yourself to maybe a few thousand rows or 10,000 rows or so. And you can pick datasets with hundreds of columns. Once again, that will probably once again cause a lot of confusion. So stick to maybe something around 10 columns. A maximum would be good. But as such, the dataset should be rich enough that you can ask enough questions and draw enough graphs and so on. Okay. One thing that you can also do And this will be great because it will really enhance your skills and your experience is if you can combine data from multiple sources. That will let you create something really unique, and you've learned how to combine data using the merge function in Pandas. Yeah, so just keep that in mind. Those are some guidelines for picking the right data set, and we'll show you some examples. But once you have picked the right data set, then next step is to perform some data preparation and cleaning. So you simply load the data set using Pandas, and then the same way we've done with the COVID data set and a few other examples. And then you explore the number of rows and columns, the range of values. So you use things like info, describe, shape, and such. So just to get some basic understanding about the data. This is like some meta information about the data. You also decide how you're going to handle missing values, maybe fix any incorrect values, maybe drop any rows that you don't want to consider. So there's some basic cleaning up that you might have to do. And you can also perform additional steps, like you might want to parse dates into the date time format. You might want to create additional columns or merge multiple data sets. So you do all of that. That's the data preparation step. And so take these steps as a guideline on what to do and not as something that you have to really stick to. You can work on the data as you see fit, but these are just some guidelines to help you along the process. Okay. So once you're done with the data preparation and cleaning, then you will perform some exploratory analysis and visualization. So what this means is you will compute the mean, the average, the sum, range, and other interesting statistics for numeric columns. So here we are still discovering, you're going one step deeper where you're looking into specific columns. Maybe you can use this, you can look at the distributions of numeric columns using histograms. Maybe you can explore relationships between columns using scatter plots, bar charts, and things like that. And also make a note of interesting insights from this exploratory analysis. So here we are not really trying to ask any questions yet. We are still just exploring what we're just feeling it out. And through that, as we plotted some graphs, we got some, we could infer some things from it, or we could form some hypotheses. So make a note of all of these interesting insights from this exploratory analysis. And then the next step is to ask and answer questions about the data. So now once you have become familiar with the data, you have looked at it in different ways through graphs and through summaries and things like that. Now you have to figure out what are at least five things that you want to know about the data set. So ask 5 interesting questions. So questions 1 through 5, and then answer these questions either by computing the results. So you can use NumPy, Pandas, the different functions that we have for computing the results, or by plotting graphs. So the questions do not have to be numeric questions. The questions, in fact, sometimes even if they are numeric questions, let's say which country has the highest population, if you're trying to answer that, you can actually draw a bar graph and use the bar graph to answer that question, right? So there's no automated evaluation here. It's more for you to explain what's going on in the data, and you get to decide your own questions. And you can create new columns, you can merge multiple data sets, and you can perform grouping and aggregation wherever necessary. And one good thing to do is, in all of this process, apart from writing the code, you should also try to write good explanations. So make it like a tutorial so that it is useful to read for somebody who is one step behind you, for somebody who has not taken this course. So in that sense, it becomes like a full report and a tutorial as well. So whenever you're using some library function from Pandas, NumPy, or Matplotlib, just explain briefly what it does, or link to the documentation that we can use the pandas.read CSV function to read a file from in the CSV format, right? Just one sentence like this, even though it's obvious to you, it's really helpful for a reader. So that's where you will ask and answer some questions. And then finally, at the end, you have to just conclude. So treat this Jupyter Notebook as a project report along with the code itself. So just write a summary of what you've learned from the analysis, include some interesting insights or graphs from the previous sessions. So you can once again copy over the code and then just include those graphs if you need to. Again, all of these are guidelines, so you do not have to stick to them perfectly. And then share ideas for future work on the same topic or using other relevant data sets. You have gathered some insights, but maybe you've not really figured out everything, and you maybe did not have the time. So you can just mention these are a few other things that you can try out with the same data set. and maybe even point to some other relevant data sets which can probably be combined using with this data set, or maybe the insights can be combined to get more to get something more interesting out of it. And this could be an idea that might help you in the future, that this is a starter project that you do, and then 2 months later you're looking for another project to work on. You can just look through the future work ideas from your current project, your previous project, and see if any of those make sense to pick up, right? So this is a very important thing to do. So do some reflection and then share more ideas while you are still in the thick of things. And finally, while working on this project, you will probably refer to at least a few dozen blog posts, articles, documentation pages, Stack Overflow answers, and some of these you might want to just note down and keep a track of. So just keep a note somewhere of the most interesting links that you found, and just link to those resources at the end of your analysis. All right. And in this entire process, from let's say step 2 to step 5, all of this will happen in the Jupyter Notebook. So document your Jupyter Notebook, write detailed explanations, use the markdown cells, use the markdown syntax, use headings, use bullet lists, use tables. So there are a lot of things you can do with markdown. So just make it a point to make it as nice as possible, because when you send this notebook to somebody, you want them to look at it and you want them to look at it and be able to understand what's going on, and also really appreciate the effort that you have put in. And that will really help you make progress, because presentation is a very important part of data science, right? So that will really help you make progress towards getting a role, or getting an internship, a fellowship, or a job in the data science domain. Okay. So now once you're done with all of this, and then you can use this, you then need to make a submission. So you can use this starter notebook, or you can just start a new notebook from scratch, but make sure to keep running jovian.commit from time to time. So here we have a project name. Just give this a nicer project name, whatever makes sense for you. Let's say if I'm working on some COVID-19 data analysis, that's a data set, a real world data set, something that is evolving on a daily basis. Okay. So I am just setting a project name, and then just use the Jovian library and keep committing the project. So here I've created sections for you in the starter notebook. So let me just make a commit first, and then I'll go through that. So here we just put in the API key and then make a commit. But here you can see some sections like data preparation and cleaning, exploratory data analysis, asking and answering questions, inferences and conclusion, and then references and future work, right? So you can just use that as a guideline, and write some explanations, write some code, plot some graphs, get some results, and keep committing from time to time. And then when you're done with the entire project, when you feel that you have something significant enough, then you take this committed notebook. So in this case, 0 to Pandas course project starter is what I've committed to. You take this committed notebook and then come back here to the assignment page, course project, and make a submission here. Sorry, and make a submission here on the make a submission form, and then click submit. Oh, sorry. So this needs to be, let me just try that again. So this is the notebook that let me just run jovian.commit. So I have committed the notebook. I take the notebook here, the notebook link, COVID-19 data analysis demo that I just committed. I come back to the course project page, and here I make a submission and click submit, and a submission will be made, and then we will evaluate it. Okay. So now what are the evaluation criteria? The evaluation criteria is this, that your submission will be evaluated on these criteria: that the dataset must contain at least 3 columns and 150 rows of data. So this is just so that it has enough of a breadth, enough information within the data. You must ask and answer at least 5 questions about the dataset. So asking the right questions is also a skill. So that's why you have to come up with 5 interesting original questions about the dataset. Your submission should include at least 5 visualizations or graphs. And once again, try to make these different, but we're not going to test if these are all different graphs, but don't make just 5 line plots. Try to use different kinds of charts, scatter plots, histograms, heat maps, whatever you can try out. Your submission should include explanations using markdown cells. So it should not be just code. It should not be just a series of code cells, because then it shows that you've not really put an effort into presentation. Presentation is an important part of data science, and especially of doing projects. And then your work must not be plagiarized. That you should not have copy pasted the entire thing from somewhere else. Now you can see a lot of these data sets are already analyzed. There's a lot of information available online. So you can repeat what somebody else has done, but just there's a difference between simply copy pasting where you do not really understand what has happened versus borrowing the right things from specific notebooks or tutorials. And it's a fine line, and it's something that you should hold yourself accountable to. But just try to, as long as you have put in some original work into the project and you have satisfied all of these criteria, we will evaluate and accept your project. And this course project, along with the 3 assignments, if you've completed all of them, then you will be able to earn the verified certificate of accomplishment that you can add on your LinkedIn profile or wherever else you want to. So these are the evaluation criteria. This is how we will evaluate your work. Now, I just want to spend a little more time talking about some of the interesting, some of the data sets that you can use for working. So we have created a list of a few data sources from where you can get data sets. So the first one is Kaggle datasets. This is the easiest one to get started with. So you just click on Kaggle datasets and you will find a whole bunch of, there are over 50,000 datasets you can pick from. So for instance, what you do is just open up a dataset and then just click download, and that is going to download the dataset for you. And I'm just going to save it on my desktop, and I'm just going to open it up. So unbundle it. So you can see here that there is a file here. So from 1976 to 2018, you have the data for US Senate. Let us open it up in, let's use Visual Studio Code to open it up. So you can see that this data is in CSV format. This data is in CSV format, and in the CSV format, you can now read it using pandas, and you can start doing your analysis. So that's one example, the US elections dataset, and there are lots more that you can look through here. You can also filter. There are a lot of filters that you can use for this dataset, for these datasets. So that's Kaggle datasets. Then similarly, you have the UCI machine learning repository. This has a whole bunch of datasets too. So here you can, for example, just click on view all datasets here, and you can see you can even filter it out with different areas, different attributes. You can see different data types and different instances, and use that. So here, for instance, breast cancer dataset. So this has around 2000 data. You can see a basic information that it contains a bunch of information about breast cancer patients, and you can found the data folder here. So here it is in a certain format called .data. You might want to then convert that format to CSV, but a lot of these datasets are also in a specific CSV format that you can directly use too. Okay. Then you have awesome public datasets. This is also another great source. So this is a GitHub repository from where you can find links to a lot of datasets in many different areas. So if you are from a different domain, like whatever domain you're from or you're currently working in, find an interesting dataset there, use that. And then you have, we also linked to a place, you have Google dataset search. So on Google dataset search, you can find data for anything and everything pretty much. So for instance, if we try global temperatures, you can see that there is some data here about global surface temperatures, and you can then get this data. So in some cases you might have to go through a few links to get the data, and you might have to look through on how to actually download the data. So I'm not sure here what, it seems like there's a lot of different data files here. But as you just go through and look through all of this information, you will be able to find a CSV file. If not, probably just try another dataset. So these are some sources where you can find these datasets, right? And whenever you get a dataset downloaded to your computer, now you will need to upload it back to Binder. So here, whenever you're working on it, you will need to just upload this data. So here, for example, you have the USA presidential election by county. I'm just going to upload that. Actually, let me upload a smaller file. So here, let me upload this 2012 data. So this is how you upload a data to Binder. And if you want to download a file, let's say you've created a CSV file by processing some other data file, you can download it by selecting it and clicking the download button. So that's something you can do as well. One other thing that you can do is when you're running jovian.commit, you can also include a bunch of files. So for instance, here in the list of files, I can include this CSV file name. So in this way, what happens is that your CSV files can get included. Your CSV files can get included along with your commit, so that the next time when you run, then the CSV file will automatically become available to you. So the first time you run commit, you might want to just include the CSV file using the files argument. So then when you commit and you check the files tab of your project, you will be able to see the file here. And when you run it, the file will already be present, so that you don't have to upload it again and again. Okay. So that's how you work. So these are some dataset sources, and then we've also picked out some specific datasets like the Stack Overflow annual developer survey, some COVID-19 data, some Google Play Store data, and a bunch of these. So these are datasets that we would highly recommend that you can analyze. And so there are some game datasets like Dota, cricket, basketball, PUBG, and so on. And then there is also data that you can download from your personal apps that you use. So things like WhatsApp, Chrome, Google Calendar, Apple's apps, Instagram, Facebook, LinkedIn. And that is also another really interesting thing to do. So now what I want to do is I want to show you a few examples of what a good project will look like. And actually one last thing that I want to mention is that apart from making a submission, you should also share your work on the forum. So a submission is more for us to evaluate your work, but then you can also go on this forum thread, the course project on exploratory data analysis, where you can share your work. And we are hoping that we see thousands of projects shared here. And when each of us share our project and then go through maybe 5 to 10 other projects, that way we learn a lot more than we would learn individually. So please share whatever you do. Please share ideas. So on the datasets thread, you can also share ideas for datasets. On this thread, you can share ideas for projects, share an update on what you're working on, how your notebook looks like so far, and keep sharing updates on a day-to-day basis and support each other. And that's how we can all create maybe 1,000 or so interesting projects. And you can also share these projects on social media and just tag us, and then we will be retweeting 4 or 5 interesting projects every day. And do try to give feedback to other participants too. Now, apart from that, there is one optional step here, and the optional step is to write a blog post. So you can have a Jupyter notebook and you can have great explanations, but sometimes it is also helpful to write a separate blog post. So you can use the medium.com platform. Again, this is completely optional, not part of the required submission. You can sign up on medium.com and you can copy over the explanations from your Jupyter notebook into your blog post. And the code cells and the outputs, you can actually embed them within your blog post. So I'll just show you an example. So here you can see that you have, this is a blog post where we have embedded this code cell from a Jupyter notebook. You can see here that you have the inputs and the outputs. So you have some code and then you have a graph. This is embedded from a Jupyter notebook. They're called Kaggle Python recipes. So you can embed code and output from your Jupyter notebook inside a blog post. So try that out as well. And if you want some inspiration, you can check out our Medium publication, right? And we will love to feature your work on our Medium publication, and we will share it with our user base. We will share it on our social media. So we are looking forward to interesting submissions, interesting blog posts, and interesting notebooks. Okay. Now I want to show you a few examples of some good projects that you can take inspiration from. So here's one. This is analyzing your personal browser history using Pandas and Seaborn by Karthik Godawat, a good friend of ours. So here what Karthik did was he used Google Takeout. So Google has something called Google Takeout, so takeout.google.com, from where he exported his entire browser history across all devices, including mobile and desktop, in the JSON format. Then he took that browser history JSON and then he converted that into a Pandas data frame. So this is what the data frame looked like, where there you had the URL and then you had the title and then you had some other information like at what time he visited the page. Based on that data frame, he extracted a bunch of features, so created new columns. So he created like days of the week, year, month, and things like that. He also created categories. So based on the URL, like if Coursera, FastAI, Kaggle, or FreeCodeCamp were part of the URL, then he categorized that as learning. On the other hand, if it was Y Combinator, Medium, or HackerNoon, he categorized that as tech reads, and then probably categorized YouTube, etc. as entertainment. So he did some categorization and created a data frame out of that as well. And so that is some pre-processing on the data. Then he started exploring the data and creating visualizations. So here he has used Seaborn to create a count plot. This is something that we have not explored, but you can look up the documentation. So to check how many sites were HTTPS and how many were HTTP, he has done some more analysis to figure out how the browsing activity varies on weekends versus weekdays. So it seems like there's more activity happening on weekdays compared to weekends. So that's great. He also looked at his browsing activity over the different months and the different hours of the day. So different days and different hours of the day. So here it looks like that most of the browsing, so between let's say 12 a.m. to 9 a.m. not a lot of activity happens, and then there's a lot of activity happening on certain nights, probably when you're binge watching something or maybe busy with work. So here a heat map is a good example, and you can see that all these graphs are things that we have covered. Then he also looked at browser visits by the day of week and the hour, again a heat map. And then there are some more analysis here. Here, this is a list of the most common Stack Overflow questions. So sometimes you don't need to create a graph. You can just create a filtered out data frame. So it seems like these are some of the most common Stack Overflow questions that Karthik looked at, and so on. So this is one great example. Then another one is just analyzing the COVID-19 data using pandas. This is what we did for the pandas tutorial. So you can see that we followed all these steps here, and you will be able to just take a data set and follow the same steps, reading a file using pandas, retrieving some data from a data, then exploring the data, querying and sorting the data. We did not do a lot of visualization, but you can see very easily how you can insert a lot of interesting visualization here. We also asked and answered many questions here. So we've asked 4 questions and answered them. So this is again something that you can review. Here's one where Prajwal used his own WhatsApp data to perform certain analysis. So here Prajwal has downloaded his WhatsApp data and he has given you the instructions on how you can do that too. And based on that, he has then converted that into a data frame. So you can probably even just borrow this function if you want to analyze your WhatsApp data. And then he's done some data cleaning. And then based on that, he's asked questions like who is the most active member of the group. So it seems like this person is the most active. And what were the most popular emojis that have been used? It seems like the laughing emoji was the most popular emoji. What can you say about the sleep cycle? So it seems like there's a lot of activity on WhatsApp happening around after 9 p.m. So these are interesting insights that you can discover about yourself, right? And then there are a few more. So here's one called Understanding the Gender Divide in Data Science. This is more around data visualization. So you can see this is from a Kaggle dataset, and here Akansha has walked through many different interesting kinds of plots that you don't normally see in Matplotlib or Seaborn. So if you want to explore more interesting plots, you can check out this tutorial. And then there is also a couple more that you can follow. Okay. So we are hoping to have a lot more examples as the course participant work on projects. So you can take your projects and then share them on this thread, discuss and share your work thread. And you can also share ideas for datasets on the datasets thread. So we have a separate thread for datasets. This is recommended datasets for course projects. So here you can check out these datasets and you can also post ideas for datasets. Okay. And I hope you're excited to work on this project. We are really excited to put this together for you. We've gathered a lot of resources from a lot of different places, and everything that we have been doing in the course so far has been building towards it. So just take it step by step, follow the guidelines, do something, try to make some progress every day. You have 2 weeks ahead of you. So there's enough time for you to find a nice data set, do some analysis, explore it, see if you want to pursue it and create a full project out of it, and so on. Right? And you can always ask questions on the forum wherever you feel stuck. You can ask questions just simply as simple as, do you think this data set is interesting to work on? And others will reply to you, even the course team will reply to you. And our final lecture next week is going to be a case study of exploratory data analysis. So in some sense, it is one project that we are doing. And so that will also help as serve as a tutorial for how to take up a data set and then do some processing on it and do the analysis on it and present some results. And we will just walk through that entire process. Get started now. And you will, hopefully we will be able to give you a lot more information next week during next week's lecture to help you further with the course project. Okay. Once again, I do get started as soon as you can, and I wish you all the best with the course project. And I hope that this will be something that you will be able to proudly showcase on your professional profile. Okay. So what should you do next? You can try out the notebook yourself, the data visualization notebook. You can also check out the data visualization cheat sheet and the other tutorials listed there, especially the galleries for Seaborn and Matplotlib. Work on assignment 2 if you haven't completed it. You work on assignment 3 and then work on the project. And as you're working on these, we have designed these assignments so that each should take no more than 2.5 to 3 hours to complete. Ask and answer questions on the forum. What we've seen repeatedly across this course and across other courses as well is that the people who have continued to stay till the end are the same people who have been the most active on the forum. Even if you make one post on the forum, that increases your likelihood of continuing till the end of the course by probably 2 or 3 times. That's what we've seen. And we also answer all the questions posted on the forum about the lecture. And a quick note, this is something that we have launched recently, a Jovian.ml data science mentorship program. Now, if you are looking for mentorship, one-on-one guidance from industry experts, especially regarding how to on building the course project, you can sign up for this program. Although this is a paid, limited and exclusive program, so we are only taking in a very small number of participants, and you will have one-to-one interaction with experts. So you can check out more details on jovian.ml/mentorship, and you can also apply there. We will add you to the waitlist, and as soon as a slot opens up, we will reach out to you. And with that, I will see you in the forums. So please stay active on the forums, ask questions, answer questions. The course website 0topandas.com. Do subscribe to the Jovian ML YouTube channels to get more updates about interesting courses and other tutorials. With that, I wish you all the best for all the assignments and the project. Thank you.